Hey guys, today I'm going to be showing you a potential way of converting between other wavelengths and visible light. So the RGB method involves integrating the values of the R, G, and B, as you can see here, using the hexadecimal color code. But it has a bit of a green bias and a bias against extreme colors, which is why I think in many circumstances the HSB method is better, even if it still might have a little bit of a bias towards green because it's in the center of the visible wavelengths. So for the hue, once again we integrate the RGB values, but then what we do is we subtract the least intense primary color's value from all of the primary color's values, the R, G, and B. So then we get just two values of two different primary colors. Then we divide those two values by the entire thing to get the fraction of the two primary colors, and you can use this chart here that I have to find what hue that corresponds to. The saturation is basically how much the more intense wavelengths are compared to the less intense wavelengths, because if the curve is just completely flat, then there's no saturation. But if there's a spike on one wavelength and there's no other light on any other wavelength, that's full saturation. And then brightness is pretty easy. It's just the total amount of light coming from a pixel compared to the lowest and highest amount across the whole image. However, I would recommend putting a cap on the amount of light the camera can take in, because if you don't, then one burst of light from one pixel can throw off the whole image. Or you can arbitrarily set a maximum value that the camera can take in across all of the images so that their brightnesses can be to scale with each other.